Hey guys, welcome to my video. So I get a lot of questions about different cap dumps to use on all these pulse motors. So this is one I haven't done in a long time. It's actually half mechanical and half MOSFET driven. So what I did was it's got these cheap little pulley systems you can get on Amazon, and then I used a reed switch. So I just made a little bracket with a bearing mount to where this can turn this, and everything's super loose so where it's not any drag. And the reed switch makes it really simple because there's no contact on it. So as it comes around, you could hear it kind of click, and makes it really a simple little system there. Makes it pulse nice, and it's kind of it's really interesting because you could change batteries at different voltages. This capacitor is rated for 35 volts, but if you use the bigger one, like this is a 100 volt one, you could use this for up to 48 volts. So it's kind of neat, and makes a real nice, crisp little pulse. So this is that Bedini motor I saw on my site, and I got it running on generator mode right now. So we have the generator SG mode, so it's on generator mode. It's on, so what you do is just give it a little spin and she'll start going. So I have this really big load on it. This is a 18 or 20 inch fan blade like I've used on most of my motors. It's a really big one. And on the Bedini motor, it seems like the more you load it, the more energy you get back. So if you look at the scope at this low speed, let's stop this. And so right now we're doing 1, 2, 3, 4, 5, 6, 7. So we have 7 pulses per magnet. So this is the on time every magnet. So when you really dim down the transistor, you could get this effect. So 7 pulses, and then we have 8 magnets. So pretty cool. You get, instead of just getting 8, you get 8 times 7 on there, and greatly improve the output of it. So right now we're running pretty low. We're right around 65 milliamps with the 12 volt battery. And then here's our little cap dump action right here. And yeah, it's really nice, really crisp. And then you can see with the voltage. So it looks like it's hitting about 16 volts right here. So kind of cool. Just a really simple. This is just a small MOSFET. I have a pull down resistor, and then this is a 4.7K resistor, and then this is 35 volts at 10,000. So pretty simple little setup, but functions really neat. So let's shut this down. I'm going to put it on the next battery. So this is 12 volt charging. Now we're going to go to 24. Like I said, this capacitor is 35 volt rated, so we can't really go past 24 at the moment, but I'll probably end up making another one of these with the big capacitors, higher voltage ones. So let's fire this up again. So now these are taller because now we're doing each square is 10. So let's reset this. So now we're doing 24 volt battery. So we're doing 200 milliamps now, and it's hitting about 27 volts, 27.6 volts, something around there. So without changing any parameters, that's kind of cool. You could just go right into the higher voltage battery without changing anything. So like I said, if you do like an 80 volt or 100 volt capacitor, this is same thing. 10,000 is this, it's just a higher voltage. Then you could pretty much go up to whatever battery you want. The reason is because on the circuit, let's put this on 10 times scale. So with the circuit, when I turn off the output, we are getting 100, 200, 300 volts out of it. So you can pretty much charge to whatever battery you want, and it's actually higher because this neon is really going off. So we'll just switch this back. So now it's dissipated out. We'll this back on normal. So yeah, pretty cool. Just a simple little thing. These are really cheap on Amazon. I think they come in a 2-pack. And then I just drilled it out and mounted a little bearing on a 1/4-inch shaft. I just pressed it in the plastic. So pretty cool. And you can see the magnet right there. I just drilled a little hole and glued a magnet in there. It's a little tiny 3/16 neo magnet. So yeah, makes it really simple to do these kind of experiments and without changing a lot of different zingers. I usually change zingers, and when you're only running at about 50 milliamps, you know, the cap dumps, they work really well, but they have a lot of circuitry, so all of these resistors seem to eat up a little power. But when you have a bigger motor, it's not that big a deal. But when you have something that's only using 50 milliamps, this circuit only uses 2 milliamps to fire, so that's really efficient. The next efficient would be mechanical, but then you're actually touching the wheel, and it could be a lot of friction and slow the motor down when you're using this little power. So this works really nice. Like I said, 4.7 and a 15K pull down with the little tiny MOSFET, and yeah, make all these the same with the thick copper. So yeah, the little reed switch works really well. So yeah, we're running at 50 milliamps. Yeah, just a little over 50 milliamps, and we're getting back 200 milliamp pulses. Yeah, pretty cool. So thanks for watching, guys. If you have any questions, leave them in the comments, and don't forget to check out my store.